Hello everybody, thanks again for joining us for the Using Vector Data and FCS Express Image Cytometry webinar. We know it can be difficult to try new software on your own sometimes, so we've scheduled this live online demo and webinar to help you out. It will be about half an hour to 45 minutes long, and we're going to give an overview of how FCS Express can help you analyze your image cytometry data generated from the Vectra line of instruments in the Inform software by PerkinElmer. So hopefully this webinar will give you a great head start on exporting your data from Inform software and taking advantages of the many features that FCS Express has to offer. So if you haven't already and you don't own a license of FCS Express, you can go to the Denovo software website, denovosoftware.com, and download a free trial of the software if you want to try it on your own computer after or during this webinar. We also have many tutorials and sample data sets available on the website to help get you started. But before we start talking about the vector data, let me tell you a little bit more about FCS Express if you're not familiar. It was developed as a powerful flow cytometry data analysis and presentation software. And many years ago, with version 4 of FCS Express, we launched an image cytometry product. And since then, the team at Denovo Software has continued to make improvements with FCS Express image cytometry, including more compatibility with various vendors and major improvements to the speed of loading images and data in the software. And now we're happy to announce the compatibility with the Vectra instrument from PerkinElmer. Now, as you may know, the main principles of flow cytometry and image cytometry overlap, such as taking multi-channel fluorescent data and plotting that data in scatter plots and histograms to look for statistically significant differences and changes. And with FCS Express image cytometry, you can take those data sets a step further by leveraging the most powerful analytical tools in our flow cytometry software to analyze those multi-parametric data sets from the Vectra and Inform software while relating back the results to the original images for confirmation of phenotypes in different populations. So FCS Express image cytometry is going to allow you to spend less time reviewing large, overwhelming data sets and analyzing raw microscopy images by using these tools that have been proven to handle flow cytometry data sets and image cytometry data sets with millions of points and allowing you access to the raw images when needed. So today we're going to go over some of the basics of exporting data from the Inform software, which controls the Vectra instrument, so that they can be loaded into FCS Express. We're going to cover how to load those resulting files, into FCS Express, and how to work with some of the basic features within FCS image cytometry to get your analysis started. So first, let me introduce you to the workflow for analyzing data in FCS Express image cytometry and getting that data to us. So there's one side of this, which is image data generation. This is what's going to be completed by the Vectra and Inform software. There's essentially three major steps where images are acquired. Image segmentation software packages like Inform software are used to define cell boundaries. And FCS Express, outside of Inform software, can read data from a variety of different segmentation sources as well. But the Inform software will also make feature extraction measurements, things such as intensities, areas, shapes, different phenotypic characteristics of cells will be measured. Now, all that data can be exported from the Vectra and the Inform software and then loaded up directly into FCS Express. So that way you can use the multi-parametric features and analysis routines in FCS Express to make it easy to generate reports, communicate your results, and publish them all within one package. So again, analyzing your data and generating reports in FCS Express is very simple and intuitive, since FCS Express shares many design features with Microsoft PowerPoint and other Microsoft Office products, making it familiar for most people. And when you start out in FCS Express, you can also start with a kind of pre-designed layout or template, just like you would in PowerPoint, to make things very easy. But our first point here is we're going to show you how to export data from the Inform software. And let's take a look at what those exports should look like and how they should be defined in the Inform software. So again, when you're exporting data from the Vectra Inform software, the place to start is adjusting settings in your view editor. Now, there's a number of settings that are important. What you're going to see here is a screenshot of the typical settings that you'd want to use. Number one here, we want to make sure that you're using the cell segmentation data. The table of contents section is where you're going to choose your components or images or image sources. You're going to want to make sure that you choose any and all of the images or channels that you want to export from. 3 here is going to be your component statistics. So these are the kind of features and measurements that are exported from Inform software. You can choose minimum, maximums, means, totals. And in general, you're going to want to use means and totals, of course. But most importantly here are the X position and Y position statistics. These are mandatory requirements for loading that data into FCS Express. If you do not check these buttons, the data will not load properly. So you must make sure that the X and Y position sets are checked here. Again, that's a mandatory requirement. And also any of the shape statistics, if you would like to include them, of course, that will come over to FCS Express as well. Now, the final setting before you export that data is to go into the Manual Analysis Export Setting tab in the Inform software. This is where you're going to choose number one here, your export directory, where you're going to save those data files. You're going to want to save the image output as TIFFs. And importantly here, you're going to want to check the component images and segmentation maps. These, again, are mandatory fields to have that data exported and importable by FCS Express Image Cytometry. So please do make sure that these boxes are checked. And of course, you're going to want to choose to export the cell segmentation data and to use the view settings. And I believe this is going to control using these settings that you set up in the view editor. So once you have those export settings set up, you'll be able to run this export, and if need be, you can always go back to the De Novo software website or in the FCS Express manual to access what these screens look like if you need to go back and review after the webinar is over. So again, once we have this set up, let's take a look at what those file exports actually look like. So here you can see we've exported a series of images from the Inform software. And you can see here that we actually have 5 files that are associated with every single data file within this folder. So you can see that these are named UL for upper left. They have a numeric sample name in here as well. And we've actually exported at the same time 4 sets of this data, right? So this is kind of what the data will look like on the back end when it comes out of the Inform software. And what we're going to be loading into FCS Express is any of these TIFF or text files associated with them. So let's go over to FCS Express and take a look at how to get that data in here. So we're going to open up an FCS Express layout. And again, this is kind of looks like a blank sheet of paper or a PowerPoint slide. And what we'll be doing is inserting plots and objects on here, just like you would do to create a PowerPoint presentation. And we're going to do that for your data from the Inform software. So there's a number of ways that you can get your data into FCS Express. I'm going to show you 2. One of the ways is you can simply drag and drop any of these data files from the export directory into FCS Express. FCS Express is going to prompt you for what type of plot you want to insert for that data, and that data file is going to be loaded into the software as a plot. So I'm going to undo that change because I also want to show you that when you go into the Data tab and Data List, you can add data files to the data list. And anytime that you see one of these select a data file kind of windows or dialogues here, you want to make sure that you've selected PerkinElmer Vectra Files from the list of available file types. And once you've done that, again, you can select either the TIFF or the text file. You can click Open. That will put a placeholder into your data list, which you can drag and drop onto the layout in FCS Express to insert that plot or that chart for whatever it is you want to analyze there. So again, getting this data into FCS Express is quite simple. Now, before we go through some of the other features in FCS Express and how to analyze some of this data, I do want to point out that we have specific user options for working with PerkinElmer Vectra data. These are accessed in the File tab, Options, and under the Data Loading category, you will see an option for PerkinElmer Vectra Options. So there's a number of options here. I'm going to explain them very briefly. The default options that we have in the software are the ones that are appearing on the screen right now, and this will suffice for loading your data most of the time. The one option that's here, the first one is for load images. So what this will do is when we load up any of those data files, the images associated with them will also be loaded at the same time. So we can do this kind of plot or point to image linking that we'll talk about in a little bit. But if for any reason you choose not to load images, maybe your images are very large and they're starting to slow down your analysis, or you have many data files and the images are actually not as important as they might be for other experiments, you can uncheck that button and we'll load in simply the raw numeric data. Now the second option here is for use default image resolution, and when that box is checked, the user can set the default image resolution for composite TIFF images loaded into FCS Express. So these are tiled images where we recreate the tiling that was done in the Vectra software, and you only need to check that box if you're working with that type of images, and that the Vectra software exported the data without the image resolution necessary for putting these things together. So if you are working with tiled images and things don't look exactly as you're expecting in FCS Express, you may want to come in here and check out these options. Now the final option here is for segmentation cell type. Now, as you may know, when you acquire data or when you perform segmentation in the Inform software, you're generally prompted to choose what type of segmentation masks you want to use, if you only want to look at a nuclear compartment, if you want to look at a cytoplasm compartment, which is essentially a kind of donut hole representation of the cell where the nuclei is included and you're only looking at things around the nuclei, or the whole cell, which is the membrane. So you do need to choose this up front when we load that data into FCS Express, which compartment you want to look at when you're looking at images in the software. And we'll come back to this when we actually load some data and take a look at what's going on. But I'm going to leave the options as default. Again, we've explained them a little bit. But as you remember, we've dragged and dropped a data file into the layout. We've chosen to insert a dot plot. You can move this, you can resize it, you can put it anywhere on the layout you want, just like you would do in a PowerPoint presentation. And also, again, if you're used to working with PowerPoint, you can insert things like text boxes and you can put in some text, you can insert shapes. Really, all the familiar Microsoft Office functionality is here within FCS Express for you to pull from and use at any time. Of course, that includes undo and redo. So if you want to remove things or make changes, you can undo and redo them. Now, when it comes to looking at this data, you can see here that if we click on the axis, we have access to every parameter that was exported, that you chose to export from the view settings. You can pick and choose whatever it is you may want to look at. And in this case, we're going to choose the entire cell DAPI mean counts. And we're going to look at that against the entire cell Sci5 mean counts. So essentially, we're looking at the mean intensity of the DAPI channel versus the mean intensity of the Sci5 channel for this image data. Now again, this is image data. I know it looks very much like flow cytometry data, but there are images associated with this, and we can access them by choosing to insert what we call a picture plot in FCS Express. You click on picture plot, you draw a plot on the page, and FCS Express will load the images that were associated with that experiment. I know it may be kind of hard to see here with our Sci3 channel, there aren't many positive events, but when you click on the axis, you can pick and choose whatever channel that you'd like to load up. So if we'd like to look at the DAPI channel, or even a composite image of all of these things, we can do that. And you'll see that if I magnify this axis to make things a little bit larger by right-clicking and choosing Magnify, that here's all of our cells from our experiment, and this is what makes up all of the dots on our dot plots, all of the cells that were segmented and used here. And you're not limited to one picture plot. You can insert as many of these picture plots as you want. You can copy and paste a picture plot if you'd like, put these right next to each other. That way, if you wanted to look at, DAPI versus Sci5 in these images, because that's what we have represented over here in this dot plot, we can do so, and do so very quickly and easily. Now, the other type of plot that we have that we generally work with in FCS Express image cytometry, it's what we call a data grid. And if we click on data grid and insert one below, what you'll see is that a data grid represents all of the individual cells or objects that were measured or segmented. And you can see here we've got about 18,000 cells that were in this image. And all the way to the right in this data grid, we actually have images of each single cell that was segmented. So we kind of move here from the dot and population level to the image level, and then down again to the single cell level. And if you remember when I talked about those preferences about which image mask to be loading up, you can see here that these look like nuclei because that's the nuclear compartment that we've decided to load up into the software. And again, that can be changed to the membrane or to the cytoplasm at any time. Now, generally, when I'm working with these data grids, I like to format them because I'm not really interested in all this multi-parametric data because I have it represented in two-dimensional plots here. But I would like to format this and choose to only show, under my parameters to display, only the images, which are always the last ones in this list. And that way, when I look at this plot, what we're going to see is that we're ignoring all of the other multi-parametric data and simply using this as kind of like a cell gallery where you can just view each of the individual cells in this analysis. So when we need to drill down and get that information, we have it very quickly. So these are the three kind of most basic components to working with image cytometry data in FCS Express, working with some sort of dot plot, the pictures or the picture plots in these data grids. And we can link all of these up together. So that way when we find a phenotype of interest in a dot plot, we can locate it back on the image. And when we locate something interesting on the image, we can locate that phenotype back on a dot plot. And this is all accomplished through gates. And before we set up gates, I do want to show you that, when we have a plot selected, we can format it. And if we wanted to change that to any other plot type, such as a density plot or a contour plot, there's a lot of different visualizations and ways of changing and formatting these things to help you kind of analyze that data and make some sense of it. So keep in mind that's always there. And I'm just changing this to a color dot plot. That way, when I create a gate by clicking on the gating tab and choosing a gate, I will draw that gate, and I'm going to be prompted to give this a name. And I'm going to call these cells interesting cells. And what you will see is that as I move this gate, all the cells that fall within that gate are appearing as red on this dot plot. And that's what a color dot plot does. It shows these events in the color that you've gated. It's also showing us the percentage of cells, some other statistics. But what you'll see on the picture plots over on the right is that certain events and certain cells are highlighted in red, and they're getting that highlighting or having it removed as I update this gate. And what that indicates is that these individual cells are cells that fall within this gated population here. So that way we can link up this phenotypic information of Sci5 positive back to any of our other images that we have here, including the Sci5 channel directly. We can see that these are Sci5 positives, and other channels like DAPI. So that way we can get a kind of better visualization of that. The other thing that you'll notice is that in this data grid on the bottom, as I select cells, these boxes, these little red boxes are appearing, telling us that these individual cells fall within that gated phenotype, and that they are part of that population. So in this case, we have some very important and useful information where we're looking at the phenotypes of cells that fall within this gate back on the image, and then we're also drilling down to see where they are at the individual cell level as well. Now, the really kind of nice thing about this is you can drill down, right? If I want to only, kind of look at, where are these super high expressors here, I can apply this by dragging and dropping onto my data grid, and it will show me those cells, and we can see that, with this grayscale image, that these are the very bright for Sci5 positivity here. And again, as we move this gate around, we can see that information for the individual cells in that cell gallery updating quite quickly and nicely for us there. Now, additionally, we can take this gate and we can apply it to any of our picture plots. So if we wanted to kind of hide all the cells that do not fall within that gate, you can drag and drop this to our picture plot. And what it will do is cut out all the cell masks for cells that do not fall within that gate. And those are all cut out as white, which can be a little bit kind of confusing when you look at this by default. But very simply, you can right-click and format this plot and choose to make the background black. Now, what that will do is hide your cutouts and reveal that we're only looking at the cells that fall within this gate as red, right? So again, we get this information very quickly about, where the cells that fall within this gate actually appear back on the image. But again, I'm going to undo those changes so we can go back and show you a little bit more. Now, the other direction we can go, we've been going from essentially 2D plots over to pictures and data grids and individual images here. We can go from the picture back to our two-dimensional plot. So say we see a kind of interesting population here. We'll make this plot larger, right? Maybe there's a few cells over here that are close to each other that we want to examine by themselves. So what we can do is draw a gate directly on the image, and we will call these important cells. We will make them bright green within the gate, so they're very easy to see. And I'll also say emphasize on plots, because we are going to be selecting just a few events, and I want to be able to visualize these very easily on my dot plots. So when I do so, what you're going to see is that the important cells that fall within this gate are highlighted. We get a statistic about what percentage of the total population they are. But also back here on our dot plot, if we make this a little bit smaller, we can see that those events that fall within that gate are highlighted as bright green, right? And we know that the ones that are Sci5 positive are the ones that are appearing within this gate. And again, as we update this gate, we can visualize, these different phenotypes in the different regions of this image. So again, very powerful tools being able to move from the image level to the phenotypic and population-based level. But again, with any of these gates, you can drag and drop that gate onto another plot, and now you will see that in that plot, we are only looking at the cells that fall within this gate. So if we wanted to do a quick kind of interpretation of this data, we can see that within this region, only 1.75% of our cells express Sci5. Down here, actually 10.71% express Sci5 or have Sci5 staining. So again, you can imagine how we can use these tools to our advantage to analyze populations and subpopulations of interest. But generally, when you're analyzing flow cytometry data and also with image cytometry data, you're not just looking at two dimensions or two parameters. You're generally looking at many kind of channels and parameters. And in this case, with image cytometry data, you generally have things like nuclear area. So you have size and shape information, which is one of those added advantages of working with image data. But what we want to do is actually start looking at phenotypes and hierarchical gates, Boolean gates, to examine these populations. So we can do that very easily. So say, for instance, we wanted to start sub-analyzing or analyzing these interesting cells, and we'll make the gate a little bit larger for now. What we can do is drag and drop that gate out. It will open up a new plot. And in this plot, we are only visualizing the cells that fall within this interesting cells gate. So again, as we move it around, you can see that that is updating and we're excluding some of these other cells here. And we can simply come in and change which parameters we want to look at. So if we then want to start analyzing, maybe Sci3 versus FitC, right? We can now start analyzing, the subpopulations of the interesting cells for their Sci3 and FitC positivity on each of these. Now, what you may notice is that, here, this is kind of a sparse plot, even if we go in and we include everything from these gated populations, and it's just due to the scaling of this data. We try and default to the best scaling that we can find. In this case of DAPI versus Sci5, it worked out very well, but we may want to adjust our axis scalings in some cases, like with this plot. So in that case, we do a right-click and format, and we can come into our axes options. And for some of this data, I'd recommend that instead of using a linear scale, try using a logarithmic scale or one of the hybrid scalings like by exponential or hyperlog. And what these hybrid scalings do is they put your data on a hybrid linear axis on a low range below a certain value, in this case 200, and you can change that. And anything above that is plotted on a logarithmic scale. But when we do that, you can actually see that this data gets kind of stretched out a little bit. We can more easily visualize things on the higher end of the data scale logarithmically, which helps to kind of pull these apart. And even if you needed to change something like the range, maybe this x-axis, you want to pull it off of the axis a little bit, so you can change this to something like minus 100. And you can see that it gets pulled off the axis for us, so it's a little bit easier to analyze and set additional gates. So again, in this case, what we would be doing is creating another gate and saying, all right, let's look at these cells, and we will call them FitC positive. And let's make them turquoise here, and we'll make them very large. And what we're going to see is that we now have a phenotype of cells that are interesting, and they're also FitC positive. And at any time, you can insert what we call a gate view, and the gate view will show you all of your hierarchical gating. So again, this is kind of Boolean gating done automatically for you here. These FitC positive cells are also and interesting cells, and you can change this hierarchy at any time simply by dragging and dropping around. That way you can break down, all the phenotypes and subphenotypes of interest. And again, when you're ready to drill down and say, all right, well, let's look at what those individual cells look like that are interesting and FitC positive, you can see here that these are these cells. This is what they look like. We can also format these data grids. One thing I'd like to do is to make the images kind of large by filling the grid cell, and we get a better kind of view of what these look like. And then we can go in and see, again, at the single cell level, what these are, and we can see that they represent 0.05% of our total representation. So again, this is some of the basics of FCS Express, moving between the kind of population phenotypic level here with dot plots and hierarchical gating, confirming those cells or those phenotypes back on the images, then using the images to kind of confirm those phenotypes back on the dot plots, and also using things like a data grid to examine the individual cells that are a component to that experiment. But as I mentioned in the beginning, reporting all of this data from FCS Express becomes very simple as well. If we want to get some statistics, you can simply click on any plot. You can right-click and choose gate statistics. You'll get all the population statistics for that graph. And again, there's a number of statistics and things that you can check or uncheck here to get you whatever it is that you need to include in your report. And we can see that very simply our important cells are 0.29%, our FTSE positives are 0.05%. We have the number of events, means, MFIs, all that kind of good stuff that you're going to be interested in. But simply, if you wanted to generate a quick report for this, we could say export, and we can export this as a PDF. We can export it as a PowerPoint presentation, as a high-resolution TIFF image, whatever type of format that you'd like, you can get it there. We'll simply export this as a PowerPoint for the current page, and we'll open it up. And what you're going to see is that PowerPoint is going to launch up. It's going to have our analysis here. We're in PowerPoint, and we're ready for publication or presentation. Whatever it is we need to do. These are high-resolution vector graphics. If you needed this for a poster or a presentation, it's all ready for you here and kind of set to go. But of course, you're never kind of working with one data set, right? In this case, we were just looking at one image. But when we exported that data, there was actually multiple data sets included from that experiment. So what I want to show you is that, we can take any of these data sets and load them into our data list, right? So we'll take this lower left, and we'll take this upper right, and we'll take this lower right. We'll load them into our data list. And what this will allow us to do is click on any of these data files and switch from what we're looking at to the new data file very quickly and easily. So FCS Express is loading up right now the upper right cell segmentation data here. And what you're going to see is that our dot plots and our picture plots and our individual cell cutouts, these things are all going to update to these new plots of interest. That way we can quickly and easily generate results. And you can see that we've just updated here, our interesting cells, our FTSE positives, all this information has updated and changed for us just simply clicking on what we call an iteration number. And what we can do is to export all this information very quickly is use what we call a batch process. And again, we're not going to cover batch processing today. I did want to just kind of cover some of the basics in the software. But another type of comparison and another type of plot that people typically use when they're analyzing flow or image cytometry data is a histogram. I do want to show that. So I'm going to insert a histogram here. And you can see that once we have a histogram inserted, we can change to any of the parameters that we have associated. So if we wanted to look at the Psi5 intensity or the DAPI intensity across, we can do that. And again, you can take any of your gates, apply them over to the histogram, and you can get that information updating for you in real time as you move that gate around. Right, so in this case, our histogram looks a little blocky because it's not many events within that gate. But if we drag the interesting cells gate on here, we can see it updating. But importantly, if you wanted to do a quick comparison across all of these images, we can simply drag and drop multiple image data sets onto the histogram, say add them as a new overlay. And FCS Express is going to load up all of that data. It's going to overlay that on the histogram, and we'll make this histogram a little bit larger so you can see this. And it's going to give them different colorings. And of course, you can format this. That way, if you want to get a kind of better display for these histogram overlays, we could choose all these and maybe give it some smoothing. We could fill the area. We could give it a transparency. And just like that, we've become ready for publication, right? We've compared the different intensities across all of these different data files. And again, as we move this gate, you can see that histogram, even across all the samples, has changed, and we can get that information very quickly and easily simply by loading that data into FCS Express. So with that, I think we've got a kind of very good high-level overview and a good place for most people to start exporting their data from the Vectra software and getting it into FCS Express so you can start using these tools. And as a quick summary, FCS Express is going to leverage all the most powerful and proven tools for flow cytometry analysis with these new features to improve your image cytometry analysis from vector-derived data sets. And the image cytometry version of FCS Express is going to allow you to move from population-based analysis all the way down to single-cell analysis at the click of a button by using these gates and other functionalities in the software. These image handling features allow you full interactive analysis between all of the plot types and all of your images, even at the single-cell level. And we're going to combine state-of-the-art visualization and plotting and data analysis, as well as advanced report generation tools, all in the same package, right? So that way we don't have to be using other things like Photoshop and Excel and other, software and presentation and image enhancement softwares. One thing that we didn't show in today's webinar is we have the ability to insert what we call spreadsheets in the software, which you see right here, which essentially allow you almost all of the functionality of Microsoft Excel for calculating formulas, references, creating tables directly in FCS Express. Also, this intuitive Microsoft PowerPoint and Microsoft Office-like interface makes the software very easy to use and understand, really for any level of user. And we have many resources, including other recorded webinars for additional topics, tutorials, sample data, and always excellent customer support, so you can get up and running with FCS Express very quickly. So if you haven't yet today, I do recommend going to our website, denovosoftware.com. You can download the free 30-day trial. You can also direct any questions you have to us at support@denovosoftware.com. And just to bring this up, again, everything that we've covered on the webinar today is here in our PerkinElmer examples and instructions area. You can click on the exporting data from the Vectra software or from the Vectra Inform software to show you this information. The very quick and easy way to get here is just typing in Vectra in our search window, and that's going to bring up all the results related to using Vectra data in FCS Express. So you can see here the second one in the list is the link that we're looking for to get back here. So importantly, I would also like to give some acknowledgments to Grace and Tam, who are researchers, and they work in the core facility at the QIMR Berghofer Medical Research Institute in Australia. They really helped us with a lot of the beta testing for this and providing some of the screenshots and export instructions for the Inform software. So we really did appreciate that. And again, if you have any questions, we'll remain on the line here for a few moments to answer them. And thanks for attending the webinar today. And we hope you have success exporting your data from the Vectra Instrument and Inform software for use in FCS Express.